Okay, in this last video in section 13.4, we're going to look at a number of equations involving logarithms. And now the idea is to convert to exponential statements to solve the equations. So starting with part A, we have log base b of 4 is equal to 1. So if I convert this to its log statement, I'd get b to the first is equal to 4. So b to the first power is equal to 4, but b to the first is just b, and so that, in fact, is the solution. All right, for part B, we have log of x is equal to 2, and just remember that when it's not written, that base is really 10, so we're saying 10 squared is equal to x, and so if 10 squared is equal to x, another way to say this is x is equal to 100. All right, for C, we have log base 3 of a ninth is equal to x. And so if I do 3 raised to the x power, that's going to give us 1/9 in return. And now 3 raised to what power is going to give us 1/9? Well, I know that 3 squared is 9, but I also need to take a reciprocal. So x then must be -2. Okay. Part D, it says log base x of 64 is equal to 3. And so for that, I'm going to do x raised to the third power, so x cubed. That's equal to 64. Now I have to think, well, what number cubed is 64? And that would be 4. Because 4 times 4 is 16, and 16 times 4 is 64. All right, part E, log base b of x is equal to 1. So this is going to give us b to the first is equal to x. Or put another way, x is equal to just b. And that's really as far as we can go. We don't know the value of b, but whatever it happens to be, x would equal that number. All right. Part F, log base b of x is equal to 0. All right, so this is going to give us that b to the 0 power is equal to x. Or put another way, x is equal to b to the 0, which is equal to 1. So no matter what the value for b is, our solution for this equation is x equals 1. All right, moving on, G, we have log base 3 of the quantity 3x minus 2 is equal to 2. And keep in mind there are these parentheses here matter. We're taking the logarithm of this entire expression. So the idea is this 3 is going to be put to the second power, and then that resulting value is going to give us what's inside the logarithm. So that's going to say that 3 squared is equal to 3x minus 2. Or put another way, 9 is 3x minus 2. Now if I add 2 to both sides, I'm going to get 11 is equal to 3x, and then dividing by 3, we get that our solution will be 11 thirds. All right. Part H, log base x of an eighth is equal to 3. And so here, we'll say that x cubed, so x raised to the third power, is equal to 1/8. And so now I know that 2 cubed is 8, but I need to take a reciprocal. So that would say that x would be what? It would be a half. Because if I cube a half, I'm going to get that 8 in the denominator, which is what I want. All right. Moving on to I, log base 2 of 8 to the x is equal to -3. Okay, so again, this entire expression, 8 to the x, is the thing inside the logarithm. So I'm going to do 2 raised to the -3rd power, and that's going to have to come out to be 8 to the x. Okay, well, what's 2 to the minus third? This would be 1 over 8, because 2 cubes 8, and I'm going to have to take a reciprocal because of the negative exponent. And now I'm saying 1/8 is equal to 8 to what power? Well, I want to take a reciprocal here to go from 8 to the x to 1/8. So x then must be -1. All right, now j, this is 2 times 10 raised to the 2x minus 7 is equal to 3. Okay, so the first thing we could do is undo this multiplication by 2. So let's divide both sides by 2. And that's going to give us 10 raised to the 2x minus 7 is equal to 3 over 2. And now the thing to really clarify here is that this entire expression 2x minus 7 is the exponent for the 10. And now I want to undo this exponentiation. So I want to convert this exponential statement to a logarithm statement. And so in order to do that, I'm going to have to do the following. I'm going to say, all right, my exponent, which is 2x minus 7, that entire expression, this is going to equal the log, and the base of the log would be 10, because the base of the exponential expression is 10. So I'm not going to write in the 10, of 3 halves. So 2x minus 7 is equal to the log of 3 halves. And now let's go ahead and add 7 to both sides. So I'll get 2x is equal to the log of 3 halves plus 7. And then for the very last step, I'm going to go ahead and divide both sides by 2 to isolate x. And notice this entire expression on the right, the logarithm plus the 7, are going to have to be divided there. So we get that x is equal to the log of 3 halves plus 7, all divided by 2. Okay, now if I would like, I could go ahead and use my calculator to approximate this. And to do that, I could go ahead and just type it in exactly as it looks. So we're looking at the log of 3 over 2 plus 7. Oh, nope. Got to get out of those parentheses, right? Plus 7. There we go. And then got to divide that by 2. So we're getting about 3.588. And that would be our approximation to the nearest thousandth. Okay. Now, a comment here also about calculators. I've been using Desmos, which is nice because you can type in expressions really exactly as they look. But if you're using a different calculator, say a TI-83, something along those lines, be sure to check these calculations and make sure that you can actually get these correct approximate values. Okay. And if you have any questions about calculators, do not hesitate to let me know. All right, cool. So now let's go ahead and solve the last one here. We got log base 3 of x squared plus 5 is equal to 2. So here, the x squared plus 5, that entire expression is inside the logarithm. So we're going to do 3 squared is equal to this entire expression, x squared plus 5. Now 3 squared is 9. And that's equal to x squared plus 5. Subtract 5 from both sides, and that's going to give us 4 is equal to x squared. Now take square roots, and we find that, oh, okay, now x can be either positive or -2. All right, and that is going to do it for this video. Thanks.